our next presenter, Ashraf.
Hello.
Hello.
Hello, yes.
Yeah. Dengar Puan? Betul?
Yes, I can hear. I can hear you. Yes, good.
Okay. Nampak ke slide saya?
Yeah, I
Tak.
can. Huh?
Oh, Asyik dah share slide. Tak ada lagi dekat saya, dekat tak
Tadi keluar lagi.
ada apa-apa.
Dia dalam proses. Dia tak keluar lagi.
Ada ke?
Okay.
Ada.
Ada.
Oh, Puan Alia ni suka Sarawak
Semua dia buat kat Sarawak ni.
Boleh mula Doktor?
Yes, boleh.
Okay. So boleh mulalah, Ashraf.
Okay, Assalamualaikum. Selamat petang to all. My project research with title Power Flow Analysis. Power Flow Analysis Grid Connected Network Microgrid in Sarawak. My name is Muhammad Ashraf bin Razak and my supervisor is Maida Halani binti Muhammad Yasim. For the introduction of the project, firstly, in recent year, there are several programs under Sarawak Energy Berhad. I am focusing on SARES, Sarawak Alternative Rural Electrification Scheme. It's one of the program under scheme Sarawak Energy that involved in providing electricity to off-grid communities in Sarawak. Secondly, in Sarawak, they have existing electricity supply. Hello, boleh nampak saya ke? Sorry, saya tak share muka tadi.
Okay, silakan.
Okay. In second point, in Sarawak, they have existing electricity supply for off-grid communities. For example, diesel generator and diesel generator that frequently used in the remote areas. The diesel generator need a higher cost and complex maintenance to its system. Thirdly, the existing standalone renewable energy in Sarawak cannot provide sufficient energy usage to communities. That's the issue that I will solve, and the problem statement of this project is intermittent renewable energy resources produced are limited by the standalone renewable energy itself. Next, the problem statement of this project. The selected area in Sarawak had been selected and the primary source to power up electricity supply is standalone solar community and standalone micro hydro system. Secondly, standalone solar community had made the problem issue due to the intermittent renewable energy resources is limited by the physical nature of the primary energy source in that area. Secondly, same also to the micro hydroelectric power also affected due to the intermittent sources that cannot provide long term of energy usage for communities in Sarawak. The micro hydro only provide the peak power produced during the water availability. Next, this picture shows the capacity of the solar panel of each household that required 1 kilowatt capacity, and the usage power produced that solar panel produce 2 kilowatt hour per household per day. The standalone solar panel has limited amount of each power produced in rural area in Sarawak. This is basic appliances in Sarawak used such as table fan, rice cooker, bulb, and television. Also the small freezer that required small amount of power. Next is at Long Manga Micro Hydro Hybrid in Sarawak. There has a micro hydro system that the turbine capacity have 160 kilowatt hour, and they have provide the power for 136 houses, and most of the population in that area, 600 people at the rural area. They have a diesel genset to as a backup supply to a network microgrid that I have designed in this system. This is my objective of project, to model grid connected network microgrid which is suitable in Long Bembang, Sarawak. Second objective is to run the simulation of grid connected network microgrid using Power World Simulator. Second objective is to analyze the power flow analysis of grid connected network microgrid using Newton-Raphson method. This is my scope of project. Firstly, to model a grid connected network microgrid. The suitable design of grid connected network microgrid, selected area which is Long Bembang with parallel microgrid on a single feeder of distribution generation. The simulation analysis of grid connected network microgrid, simulate a grid connected network microgrid from the rural region in Long Bembang consists of solar home system and micro hydro system. Thirdly, scope of my project is power flow analysis of grid connected network microgrid, which is involves the Newton-Raphson method in analysis of my project. This picture shows the rural electrification coverage is end of 2017 that have 90% electricity have supply in all area in Sarawak. My location at the circle red of the Sares project that I implement were the network microgrid near to possible grid connected as the main sources of the system. This is a summary of literature review. I'm focusing on the author of the article that finding the parameter for the load sources and load, parameter of the line, power at bus and line losses. Secondly, the author that I focus that finding out of decoupled power converter structure and the impedance data for benchmark network line. And the thirdly author is focusing finding on rotor angle stability, frequency stability, voltage stability, and reactive power. Next, the author that I focus for the finding of analysis more focus on voltage, frequency, and power balancing control in islanded mode in islanded microgrid. Secondly is power interchange in grid connected microgrid. Next is I'm focusing on finding generalized power flow formulation and case studies of the Newton-Raphson method. And lastly, for the literature review, I'm focused on system performance during extreme event in network microgrid, then global renewable power generation from various sources such as solar or micro. This is my flowchart of project. Firstly, I identify the problem that the location issues for the communities, and secondly, review of past studies and project on power flow analysis. Thirdly is gathering data and information from the previous past. Fourthly is simulation part. I'm focusing on design on grid connected network microgrid. Then I run the simulation grid connected network microgrid. If I have trouble of if I have any trouble on design grid connected network microgrid, I will troubleshoot the error or the failure, and if I achieve the objective, I will come with the result that analyze the power flow analysis on a grid connected microgrid. Next, I move to the design of a grid connected network microgrid. I show the utility grid as the primary source and the network microgrid such as solar, micro hydro as the uh, second sources of the network microgrid. And I uh, saya keluarkan diesel generator in case any interruption at power supply, and I have put uh, energy storage at each of the standalone renewable energy to store the excess energy. And I also put energy storage for the utility grid for network microgrid to power up network microgrid in rural area. I have uh, I have connect the utility grid to the solar solar community to the 3 kilometer. I also connect the utility grid to the line distance to micro hydro. I also connected the utility grid to the diesel generator as backup supply of the system that 1 kilometer. Next is as a conclusion, in future the design of grid connected network microgrid can be used for rural region in Peninsula Malaysia and especially Sabah and Sarawak to electrify full of electricity coverage. The network microgrid will power up more electricity in rural area with combination of the traditional power system distribution. In this research, I apply the knowledge of power system provide a new design of grid connected microgrid in distribution generation existing in Sarawak. That's all for me, sir, madam.
Okay, thank you, Ashraf. Actually, I have one question. It refer to your design. I think the power. Okay,
This
so actually, I see based on this figure, I see you are using 100 megawatt solar supply. Am I right?
uh, Puan, I have simulate the system, but the value of in this solar panel that is not uh, uh, specific. I can change the value. The
Okay,
the network microgrid required small amount of watt power. That not the specific.
okay. How we want to select this power?
Uh, I have shown in the figure earlier that the solar panel produce 2 kilowatt hour uh, that I show the that I show the power consumption uses in the each household. And if I select the design of solar panel, I will use the small amount of power at in around 2.5 megawatt, madam.
Okay. All right. Okay. Thank you. So Dr. Zikri, any question?
Regarding on your schematic, is this your, I mean, you just simply create your own idea, or is this the real, from the real power plant?
I create the design based on literature review that I put in chapter 2
No,
and chapter 3.
my,
That
why you know why I ask this is because in typical grid, if if you begin from generation, then it should feed to transmission line. But here, I imagine this. That's, I think perhaps when Maria asked you just now is because
yeah,
um, the wattage. I mean the bulky. It start from the generation, right? So typically you want to transmit the huge power to the long distance. But here you just simply tap from generation to your microgrid system. That's why I think perhaps that's the argument point, Maria, is it?
Yeah, yeah. I'm
So
confused.
yes, yeah, we
I
confused.
I I put the network microgrid in low voltage level, doctor.
But okay, then you should connect this microgrid system to distribution. That's why I asked your friend your Shafiq now also. No, Shafiq, yeah, Shafiq and
Shafiq.
Samim, and also I asked same
Yeah.
question. Because when we talk about microgrid, it is something related to distribution. It's not about from generation, and then you simply directly tap to your microgrid. So I'm quite surprised when you do like this way. Are you sure? Then please double check. That's why literature review is extremely important. Then you please double check. To me, I think this is not make sense for microgrid project. Double check. That's all for me.
Okay. Thank you, sir. I will noted that.
Okay. All right. Thank you very much. Okay, so
Thank
we
you,
go
Pamalia.
to, okay, welcome.
Thank you,
So we go
doctor.
Okay.
to our next presenter. Nur Atira or Cairo Bairia?
Kawalia.